So hello everyone. In this session, we'll learn about the basics of the Pig Latin programming language. In the last video, we have seen about the Pig architecture and how to execute a Pig program, what are the different ways for that, and the basics about the Pig architecture and Pig Latin also we have seen a bit. But in this particular class, we'll go through with the Pig Latin programming language with covering all of the basic things so that you can start with that. So first, we'll know that for each and every programming language we have the data types, right? For C, C++, Java, Python, whatever the programming language you know, there we have the data types and we have the schemes, correct? So here also we have the data types and schemas. So the data types are very simple over here. It is as the Pig has 6 simple atomic types and 3 complex types. So 6 simple atomic types are also very simple, similar to the 3 complex types, which are also simple and easy to understand. So we'll go through one by one. We'll first go through with the atomic data types in Pig Latin. So the atomic data types are first, it to be known that atomic data types are those data types which are used for storing a single value. Yes, like integer. We have integer which is signed 32-bit integer, it stores. We have the long which stores a long value. It float stores the float value, double stores the double value, character array holds the array of the characters in Unicode UTF-8. Byte array holds the byte array, that's the binary objects. So these are the 6 atomic data types we have in Pig Latin, and it's very simple to understand. I'm not going through in detail what is integer, what is long, and what is float, what is double, what is character array, what is byte array. Those things I'm not going to get in detail because these things are easy for you. As you have come up to this level means you understood these things. I'll go through in detail with the next concept, that is the complex data types. Complex data types are the specific data types. Actually, it's special to Pig Latin programming language. So complex data types are specific to this Pig Latin programming language. And the first complex data type we'll learn here is regarding the tuple. What do you mean by tuple? A tuple is nothing but in RDBMS table, a row is equivalent to the tuple in Pig Latin. So suppose there is a row. Row means a line of data with the values of its corresponding property or the column name. So 12.5, hello world, and -2. It's a tuple. Yes, it's an unordered set of fields. There will be no order in the fields, actually, the field values. It is often known as the row in a relation. Relation means a table. So if you define a row of a relation, then that is equivalent to a tuple. It represented by fields separated by commas, all enclosed by a parenthesis. We'll go through with this example one by one. First, to try to keep this thing in your mind that a tuple is nothing but a row in a table. A row of values. A row has value. Now, suppose one student table is there. In student table, we have the first student detail as the student serial number is equals to 1, suppose, and student name is equals to Abhishek, and student address is equals to Bangalore. So 1, Abhishek, Bangalore is a row in this particular table, and that will be a tuple in Pig Latin. Next, we'll learn about the bag. Bag is a collection of unordered set of tuples. Collection of unordered tuples, actually. So bag is an unordered collection of tuple. See this, there is no order. This has come next, then this has come after that. First one is 12.5, hello world, -2, and then it is 2.87, by world, 10. It may be in opposite order also, no issue. It will also be a collection of different rows will be known as the bag. A bag is simply, you can understand in this way that a bag is a bag of tuples. That's it. So an entire relation, an entire table is a special kind of bag. It is known as the outer bag. Each and every relation has many tuples, right? So all together is an outer bag. So what is the inner bag then? Inner bag is a bag that is a field with some complex type. A bag is represented by tuples separated by commas, all enclosed by a curly bracket, as you can see in this example. It is separated by comma, right? This comma is separated over here. Which comma is separating? This particular comma is separating this concept. Correct, na? This comma is separating this. This comma is separating this particular two tuples. This is the first tuple and this is the second tuple. It is separated by the comma, and the entire bag is represented by the second bracket. So as you can see that the tuple is represented by the first bracket, a bag is represented by the second bracket, that is the curly bracket, and a map is represented by similarly in the third bracket. See, and this is a map. Map is nothing but a collection of key value pairs. So one key will be there. After that we have a hash, and that hash, right hand side of the hash will have in the value. Yes, many key values can be separated by a comma, and this map is represented by an inner box of third bracket. So you can see that here you have opened the third bracket and you have closed the third bracket here. Correct? So tuple is represented by single bracket, the first bracket, bag is represented by the second bracket, and the map is represented by the third bracket. I mean, the values are represented by this. Users can define schemas for relation using as keyword in Pig Latin. So as keyword is very much important if you need to provide the schemas for a relation. Keep one thing in mind, relations are not mandatory in Pig, unlike SQL. In SQL you need to create table, right? And create the schema of the table by using the create table statement, create table command. Then only we can go further with any operation with the relation or table. But in case of Pig Latin, we don't require as keyword as a mandatory one. It's not mandatory. You can define this as part or you may not define. But if you define, then it will create the schema. So it can, this as keyword can be used with the load, stream, and for each operators, and store operator also. Yes. So in the load statement, you can see this in particular example. What we are doing in this load statement, we are loading a particular table, which this table is loading from the tutorial data. Then the next folder is excite -small.log. So from this particular location, we are loading this particular file. Correct? So by using the load command, and when you are loading it, we are loading with this particular schema. That is, the first value will be the user, that is the first column name is the user, which will hold the data of the type of character array. The next column name will be the time, which will be holding the data of the type long type of, and the third column name will be the query, which will be holding the data of the type character array. Yes, it will be stored into the file log. This is the grunt shell of Pig Latin. As you have seen in the last video, all these things, so I know that it's very easy for you to understand. Now we'll see about the expressions and functions in Pig Latin. So expressions are also a very simple concept. I'll try to go through as quick as possible, and I want to make this video as smaller as possible and as concise, but it should supposed to give all the knowledge to you also, right? So a constant, what is a constant? Any value is integer, it's float, or a string value. Any value can be, see here the numeric values and the decimal points all are treated as what? Constant over here. If you give L, or L is applied when the number is long, otherwise this will be taken as integer. Similarly, if you give F, then it will be taken as the float. See here it's written, otherwise it will be double. See, if the F or capital F is appended to the number, it will make it float, otherwise it will be considered as the double number, and this is anyhow, as it is inside the single inverted comma, it will be considered as the string constant. Similarly, we have the basic arithmetic operators like plus, minus, multiplication, and division, and no need to explain it. We have the sign of a sign, plus sign, and minus sign. Minus sign, the minus x. If there is some value of the x, then this negation minus will change the sign of the number. Otherwise, plus is by default. So it's is very quite similar to the C++, Java, and Python, right? Cast is for the type casting. So suppose x is a value of a type, of a certain type. So it is a type of the float type. X is suppose the float type constant value, and if you have to typecast to integer, then you have to write down within the first inverted within the first bracket the type. T stands here for type. So you have to, if you convert this float x to int, then within the bracket you have to write, instead of t, you have to replace t to int, integer. Then it will be a integer type. A float will be converted to integer. Similarly, we have the modulo operator. Modulo will be taken definitely the remainder of x divided by y value. And then conditional operator, we have the C++ and Java, all they have the same conditional operator, right? If the condition of x holds true, then y will be printed, otherwise z will be printed. Next, we have the comparison operators, expressions, I mean conditional statements like double equals to. It means that if two numbers are equal, then it will be true, otherwise false. In this case, it will be not equals. It will check that both two numbers are, there's a left hand side and right hand side numbers of this operator is should be not equals. And this is the less than sign, this is the greater than sign, this is less than equals to, this is the greater than equals to. No need to explain. Then we have the pattern matching. If you want to check the pattern of a particular thing, then in Pig Latin it's completely copied from the Java. Java's regex expression is there, na? It takes Java's regular expression format, regex. Yes, so x matches then this regex statement you have to give. This x is the particular value. You can write down any particular statement, any particular constant for that. Suppose Java space matches space Java dot asterisk. So that thing should be matched with this particular example. We'll go through with that. Okay. So all the things we are teaching over here in the next lineup of this of the same video tutorial, we're learning all these things with practical examples. And here we have null. For null, we know that it checks that if you write down like x is null, then it will check that the value of x is equals to null or not. And if you write down is not operator, then it should check that x should not be equals to null. If it is not equals to null, then it will be true, otherwise false. And this first example, if it is really null, then it will be true, otherwise it will be false. We have the boolean also over here, like C++, Java and Python. In Pig Latin also we have boolean, and we know that for boolean and operation both should be true to be a true, and for the or operator any one of the statement should be true to be the entire statement to be true. So here x and y both should be true to make the statements true, or here in this example x or y any one should be true to make the entire statement true, and not x will make true to false and false to true. Okay. So now we'll go through the built-in function in Pig Latin. So built-in functions in Pig Latin are also very simple, and if you know about any of the programming languages of C, C++, Java or Python, it will be very easy for you to understand. So we have the average function over here with the same name of AVG. So in Java, if you have gone through with the C, C++, it's easy for you to understand, right? In the grand shell is the Pig Latin shell. So here you're writing AVJ, and any expression you provide, that expression's average value will be taken by the Pig Latin compiler. Yes, an example you have given over here, you are writing student underscore details dot marks. So student underscore details is a relation, it's a table in Pig Latin, suppose. Yes, imagine. And there we have a column name marks, and we are fetching all the marks values and making the average of it. How we'll do it? You have to write down count. You have to call the user defined function, the system defined function, built-in function, and then within that you have to pass student underscore details dot marks. Next we have the concat. So concat will do definitely concatenation of two strings, as simple as that. So suppose one first name you have, another you have the last name. So these two are the constants you have, and you want to put in between underscore. So what we'll do? First name, comma, underscore, yes, within the double inverted comma, and then the last name. So what will be the output of this? If you call this concat built-in function, output will be the first name underscore last name. Similarly, we have the count. What will do with the count? It will count the number, okay, of tuples in a bag. Yes, so if you pass this expression as a bag, then in this bag, how many tuples are there? That will be returned back. That will be counted up. So student details dot GPA. So here you are giving what? You are giving from a particular relation, you are giving a particular column. So on that particular column, how many values are there? That will be returned back. So what you are giving into the count, that will be depending upon that, the count will react. We'll see these things, okay, in detail with examples. Now we'll see about the diff. What the diff will do? It will compare two fields of a tuple. Two fields means two columns of a tuple, of a row. Yes, if the two fields are bags, then what will happen? It will return the rows that are in the one bag but not on the other. And if the two columns are the values, then what will happen? It will emit the tuple where the values don't match. So suppose this difference is there, you are differencing between expression and these two expressions, employee sales and employee bonus. So depending upon the employee sales and employee bonus, the result will be there. Similarly, we have the built-in function max. Is very easy actually. Max will get the max value for a particular expression. So here it will give what? Student details dot GPA. The maximum GPA will be returned back by the max built-in function. So this mean will do what? It will do the minimum value of this student details tables GPA field. Size. So it will calculate the size, will calculate the elements, the number of elements that will be returned back there. So if you pass within the size built-in function as an argument, if you pass a bag, then it will return you back how many tuples are there in this particular bag. Yes, and if you pass a tuple, then it will first count that how many elements are there on that particular tuple, on that particular row. Yes, if you pass a character array, it will see that how many characters are there to make this character array. If you pass a byte array inside this built-in function as an argument of this built-in function, then it will count how many bytes are there in this particular byte array. Yes, for suppose you are passing a numeric value, then it will always return 1. So here in the size, you have to pass the expression. If you pass back, the number of tuples will be returned. If you pass the tuple, the number of elements will be returned. If you pass the character array, the number of characters will be returned from that which making this character array. If you pass a byte array, then the number of bytes which constitute this particular byte array will be returned. Similarly, we have a next built-in method, that is sum. It will take the sum of any expression. I'm not going to explain this. This is very easy. Whatever the sum will be getting. Tokenize is very important. So this tokenize built-in function, this function is very important. What you'll do, whatever the expression you pass now over here, that expression will be converted to bag of words. So it's a new terms maybe you're coming to your mind, right? You're hearing first time maybe. So what is that? What is the bag of words? Suppose you're passing in this expression, you're passing a string line you're passing. So that string line will be divided by number of words. How? By default, word will separate. Yes, I mean one string. Suppose this is Academy of Fine Learning. So how this is Academy of Fine Learning, if you pass as an expression, then this will be separate. It will then will be separate. Academy will be separate. Of will be separate. Fine will be separate. Learning will be separate. These separate words will be generated in a bag of words. As an each word will be a tuple in this particular bag. One bag will be generated. On that bag, what will be happening? Number of tuples will be there. The number of each tuple will be each word actually. Now, how you will separate that? How will you separate? You can separate by using this field delimiter. That you want to separate by space. In this example, I separate by space. You can separate by space. You can separate by comma. You can separate by asterisk. You can separate by parenthesis. You can separate by double quote. Whatever you wish. Yes, so tokenize will make the token of a single line. This expression is empty. It will check that a bag or map which is passed inside this particular built-in function as an argument is empty or not. Yes, so suppose is empty data is getting this particular result which has been calling this built-in function is empty, employee cells. Now what this particular thing does, it will list the empty bags from the employee cells, yes, in the group using the isEmpty function. That's what you're doing over here. Employee cells, we are getting that if it is empty or not. Yes, if then you are filtering the co-group data in this particular piece. This is a particular file already available. So you're filtering by if it is the empty or not, and that will be stored to the isEmpty data. Now there is two very important functions which are actually lots of the time used in Pig Latin, and very important. These two functions are these two built-in functions. What are these two? These two functions? One is the load, another is the store. So these two functions in Apache Pig Latin, it related to the data access, how to data load and how to store, where from to get the data, where to fetch the data, and where to keep the data. Yes, so these functions, there are some of the functions which are used with the load and store. Yes, with the load and store functions, we use some of the functions. So we'll focus on these functions now. One of the most important function is the pig storage. Pig storage, with the load and store functions, we will use it. One example I'll give. This is the store functions. Okay, see this. This is the store functions. Actually, it's a store command which will be using this function. So this store command, store function is doing what? It is getting this student into this particular line from this particular HDFS location, this particular file. We're getting it using what? Pig storage comma. So what is this pig storage comma? What is this pig storage comma? So based on the comma, whenever it will appear, it will get this particular data. Yes, it will depend upon this comma. It will first load this data nest. It will store over here, right? Based on where this, if there is a comma, it will separate. I'll give another example here. See this. We are loading. Yes, what we are loading? We are loading this particular text file. this text file in the HDFS and the folder pick data, and in student, the name of the file is student underscore data.txt. How we are loading it? Based on the pick storage, we are calling the using, there's a syntax. You have to write down using space, the name of the function is the pick storage, right? Within the bracket, what you're writing over here, comma. So whenever there is a comma in this particular line, this particular text file will be loaded, right? Student data.txt. Whenever it will be loaded, based on this comma, it will be separated. Each value will be separated. Suppose the value is 1 comma Abhishek comma Bangalore. The first, as I gave an example before, now one is the student's roll number, name is the Abhishek, and the third one is what? City, address. So that is Bangalore, 1 comma Abhishek comma Bangalore. Then the next student data is suppose 2 comma Ram comma Delhi, correct? So these commas are there in the data set. This data set is in the student underscore data.txt, correct? So for each comma it will separate and it will store in this particular schema. So in this schema, while loading is defined by using this as command. So as, inside there we are telling that there is a schema we are going to define. The first in this particular schema of the table, ID will represent what? Integer values. First name will represent or hold the character array, last name will hold the character array, phone number will hold the character array, and city will also hold the character array. So whenever this comma will appear, so in the ID in the first line 1 will be stored, then the first name it will be storing Abhishek, and in the same way, I'm giving this example is not suitable over here, but suppose then okay, to match with this particular file, we'll write down ID is the one, first name is Abhishek, and the last name is suppose Subba. Yes, and the phone number is 1234 and city is Bangalore. So in ID 1 will be stored, in first name Abhishek will be stored, in last name Subba will be stored, and then the phone number 1234 will be stored, and city Bangalore will be stored. In this way, the entire data will be stored over here. It will be loaded actually. In this particular, the data will be loaded from student underscore data.txt, and it will be loaded into the Pig Latin using this particular schema. Okay, so as you can understand that how this pig storage is used for storing and loading the data. So here you are storing it, right, the student data into this particular file in the HDFS. How? By using this comma. When you're getting this comma, you are putting this particular data over there. Similarly, we have the text loader. It will load the unstructured data actually to pig. So this unstructured data is loaded to pig by using the text loader function. Similarly, we have the big storage method, which is used for actually machine readable format data. That is used for actually to store temporary data that is generated between the mapper and reducer. So if you want to deal with that, it will be machine readable data, right? To make use of this, you have to use bin storage, this particular functions. Now we have bag and tuple related functions. Bag and tuple related functions are very much important to deal with the bag and tuple in Pig Latin. So the first method we'll run over here is that toBag. toBag will do what? It will convert 2 or more expression into a bag. Yes, so you can see that I'll go to that example over here directly. You can see this example. So for each is like a loop. For each is a loop which will go through with this emp underscore data. This data is already available. Okay. So this employee underscore data will be traversed by for each. How it will traverse? Based on the column names. Suppose it has the 3 columns. So for each column it will start traversing. Yes, this generate is also a syntax of this for each, then expression, this particular table, then generate toBag method. Now we are calling toBag. What we are doing over here, we are putting to a particular bag with the value ID, name, age and city. Yes. So this ID, name, age and city of each employee, you are retrieving from the employee underscore data and converting to the one bag, right? Yes, in a tuple, sorry, not a bag, into a tuple. So these tuples will be generating a bag. So we are storing into the variable toBag. Are you clear? Yes. So a bag is being created from the employee data by using the toBag built-in function. Similarly, we have another method top, and this method is very built-in function is very easy. Top n tuples will be retrieved from a particular relation. So this relation name will be at the last. The first value, integer value, will be the number of top tuples you are going to suppose that you're going to fetch. Suppose for example, you take a very simple example that suppose you want to fetch top 5 columns, top 5 tuples from a relation employee data. So you'll write down here employee underscore data, and if you give here 5, then it will fetch top 5 tuples. Yes. So how we are doing it? By using the for each. For each is for traversing the employee group. So we are making one group. We are giving the name employee underscore group, and how we are getting it? Top is equals to top 2 comma 0 comma employee data. Yes, and generate top. In this way we are getting this top n data. Yes, based on the second column actually you are doing correct now. So two tuple method will convert one or more expression into a tuple. See this, two tuple is doing in this way. We are rotating employee data and generating two tuple, ID, name and age. So what you're doing basically, you're converting the ID, name and age of each record into a tuple. Yes, so each ID, name and age which we will getting from the employee underscore data, that will be stored to the it will be created as a tuple with the value ID as the first value, name as the second value and age as the third value. Similarly, we have the top 2 map. What the 2 map will do, 2 map will create a key value pairs actually. Yes, so one or more expression, I mean if you want to convert to the key value pair, then we'll use the 2 map here. So name and age. So for each name it will be assign value age. So it will be like we are mapping it with a key value pair name hash age. Yes, are you getting it? So it will be stored in the 2 map variable. So for each space employee underscore data, generate 2 map within the bracket name comma age. So name will be the name which will be fetched from the employee data, and age will be also fetched from the employee data, and it will be 2 map will be used to make a key value pair among the name and age. So we'll go through the important string functions which will be available into the Apache Peak. So again, the string functions are very easy to understand, and it is, I mean, most probably you have learned in C++ the same thing. So ends with built-in function. It will check that for a particular string, suppose this is the first. There are 2 parameters, right, in ends with built-in method. The first parameter will check what? The first parameter will be provided with the string, and the next parameter will be provided with the another substring. Yes, it will check that this string is ending with this substring or not. If it is true, then it will give the response back as true. Similarly, starts with that this string is starting with this substring or not. It will check. Yes, this first string, this string should be started with this second string. So string comma substring. So substring should be the first few strings, the first few characters in the string. Similarly, substring, string, start index comma stop index. So it will make a substring from the given string. So the first argument will be the entire string, which will be make as the substring by the substring built-in function from this start index till the stop index. Okay. Now the next method is equals ignore case. So what is this equals ignore case? See, the string 1 and string 2 will be compared without caring for uppercase and lowercase of it. That is equals ignore case. Okay, the comparison without considering the cases. Now next we have index of string comma character comma start index. So what it will do, it will return the first occurrence of a character in a string searching forward from the start index. So this to elaborate it, suppose this is a string. The first string is, suppose let the first string is hello, okay, and the character is O, okay, the character you are providing is O, and the starting index is 3. Then will it work? Yes, it will work, because string is hello, HELLO. So H in the 0th index, E is the first index, L is the second index, and the next L is the third index, and O is the fourth index, correct? So in starting index 3, if you give H, E, L, correct? So from the L it will start finding the character O, and it will find it out in the fourth index. So that will be printed. So index of in this particular string where this character lies from, and that will be find out from this start index. Keep this thing in mind. Yes, we have the index of optimization with this start index value. This is an integer value definitely. Now last index of expression, it will check the last, it will return the index of the last occurrence of a character in a string. Searching, it will search the backward from a start index. So sorry, it is not written properly. This last index of is having the same syntax of that string and character. Okay. Now LC first, lowercase first. LC stands for lowercase first in this expression. So it will convert the first character in a string to a lowercase. So whatever you will pass in the expression of this expression is a string value. Okay. So whatever you will pass inside this string value inside this built-in function LC first, that first character will be converted to the lowercase. Similarly, the opposite thing is that UC first, uppercase first. The first character will be converted to the uppercase. Then upper expression, it will return this string. It will be converted to the uppercase completely. Whatever the string will pass, that will be converted to the uppercase. Similarly, lower expression will do the opposite thing. The entire string will be converted to the lowercase. Now we have the replace string comma old char comma new char. What will do? It will replace the existing characters in a string with a new character. Yes, so whatever the old character, it will be matching right in this string, that will be converted with the, will be replaced with the this new character which is in the third argument. And trim expression, so this trimming is nothing but removing of the white space at the beginning and end of a character. So whatever the beginning and end of the string. So in this expression we'll pass some string, right? So the beginning of the string, if there is a white space, and the end of the string, if there is white space, that will be trimmed out. Sometimes by mistake we provide space right at the end of the string. Suppose you have written your name, and after pressing enter you have given a space. So after your name, one space is already there. So while searching you will not get any match with your name, right? Because your name is unique, because no other names has a space in their name at the end of the name, correct na? So you need to trim it, then only the search engine will work properly. So there's an example where we need this trim function. Now we'll see about the important date and time functions in Apache Pig. So first example is what? The first example is toDate. toDate will convert, this milliseconds will pass. Okay, this millisecond is a date time object. Yes, are you clear? If you pass it to the toDate function, it will convert it to the date. Similarly, current time, this particular built-in function will return the date time object of the current time. The current time will be retrieved in a simple word. Similarly, we have the get day, and if you pass the date time, then what will be happening? Today's date will be returned. Then get hour will return you the hour of the day from the date time object. Yes, so this date time object can be get by using current time. Current time will give some time, right? So that will be a date time object. So current time will return something that you can pass inside the body of the get day and get hour. Similarly, you have the get millisecond, get minute, as the name implies. Get millisecond will get the millisecond, get minute will get the minute, get month will get the month, and get second will get the second, get week will get the week, and get week year, and similarly get year. All these things will be easily understandable. As the name implies, the method name implies the same thing it means. Now days between, if you give two date time object, then it will calculate the difference between these two date time. Suppose first January 2021 is the first date times value, and the next date time value is something other, 30th. Then it will give the difference between the 1st January and the 30th January 2021. The difference is 30 days. It will give that particular value. Similarly, we can see the hours between, the millisecond between, minutes between, months between, and we have the seconds between, weeks between. years between and all these things. This particular PDF I'll share into the in the description of the video, so that you can go through with that, and you can click over there and you can go to the tutorialspoint.com and you can see these few examples. Okay, I just want to make this video smaller simply because these things, just to see a single example you can understand. It's such a simple thing. Now math functions. Each and every programming language has math functions, right? So Pig Latin programming language also has the math functions. We have the ABS. So math functions are also very easy. Okay, it's like the older things which I've learned. So ABS will do the absolute value of an expression. Absolute value of an expression. The math expression will pass inside the ABS method. It will provide the absolute value of the expression. CBRT will give the cube root of an expression. Ceiling with the ceiling value will be provided. Okay, rounded up, the nearest integer value will be provided. Floor built-in method will do, built-in function will do what? It will get the value of an expression rounded down to the nearest integer. So floor value, ceiling and floor, suppose 2.5, the ceiling is 3, 2.5 the floor is 2. So that thing will be, you'll get it from this. Random. What is the use of the random? Random, to get a pseudo random number will be generated. That will from the range of 0 to 1.0. Yes, in this range, whatever the value was there, the value will be generated. Similarly, we have the round method. Round built-in function will do what? It will get an expression, it will round it to the integer value. Yes, are you clear? Suppose the float value 2.5, 2.2 is coming, so round will give 2. Yes, and if it is a long value, it will if you get a double value, then it will round to the long value. Double value means the large decimal point values will be converted to the above the range of the integer, then it will convert to the long value. Now SQRT, no need to explain, as the name implies, square root of a particular mathematical expression will be fetched back. Now we'll go through the relational operator in Pig Latin. It's very important, and it's a bit something that it's unique and you should supposed to learn. So give focus from here. So load is a relational operator. What the load will do, it's like a command. Okay, it's like a command. Load is like a command. All the relational operators are like a command only. So load will do what? Load will load some value from the either from the local file system or from the MapReduce file system. The HDFS file system. So it's a relational operator. It will be using in this way. See this, I'll give the direct example. This is the example. This example, if you can understand, then you understood load. So load this particular relational operator you have written, then you have to write down the path. This is the info actually. It's a file that is required to load. You are going to load this file. This file is in the root, then pig example, then pssplit.txt.